This is part 4 in the SMC Familiarization Series. This segment focusing on post-processing of SMC parts. I'm Rob Holcomb, Engineer and Product Manager for IDI. The previous segment discussed the compression molding process, which ended with a part loaded into a cooling fixture. It's now time to finish the part and send it on to assembly. As with most molding operations, SMC parts have an inherent amount of flash at the parting line or shear edge of the mold. Flash is a resin-rich excess of material that ensures the part fully filled and consolidated. There should be some flash on any part. Removal can be achieved with something as simple as a knife or file run around the edge of the part. More advanced operations may employ a multi-axis robot with rotary end-of-arm tooling like a router to remove flash. If the cooling fixture is designed carefully, it is possible to deflash the part during its cooling phase. In addition to cutting of excess flash, interior details like holes, knockouts, windows may also require cutting. These areas are typically molded over with a very thin layer of SMC called a mash-off and can be routed out after molding. SMC formulations vary greatly. Some are designed to ship as molded and are appearance grade out of the mold. Others are designed to be coated in some manner. Thanks to the nature of the thermoset reaction, SMC molded parts can withstand the high temperatures typically associated with commercial e-coat and paint then bake lines. It is possible to optimize the coating chemistry with the SMC chemistry, and IDI is happy to work with our molding partners, coating partners, and their coating suppliers to find the right solution. One or two-part bonding is common with composite parts to secure them to one another, or to other substrates like metals, glass, or other plastics. As with paint, it may be possible to optimize the bonding chemistry for a given SMC formulation. Again, due to the nature of thermosets, the molded part will be able to withstand the high temperatures associated with two-part bond reactions and curing. Besides chemical bonding, it is also possible to place various fastener types directly in the mold and to flow the material around the insert, making it a permanent component. This process is called overmolding and is a very reliable way to add threaded inserts to your assembly without a secondary process. SMC has the unique ability to flow to fill ribs, webs, overmolded inserts, corrugation patterns. This is an important consideration in material choice for a project because it can greatly reduce or eliminate the number of subcomponents and subassembly operations required to produce a finished assembly. Where a stamped component may have an outer aesthetic surface, an inner support, and a welded or riveted interface between the two, the compression molded part serves as both aesthetic outer and substructure unto itself, eliminating a part and process entirely. Once all finishing and assembly operations are complete, the part is ready to ship. SMC won't corrode in transit or storage, and with greater design flexibility and typical weight savings, benefits can extend into storage space, dunnage type, shipping weight, and volume. Lighter parts with fewer subcomponents, which are simpler to rack and store, all speak to operational efficiency and excellence. This concludes a brief overview of post-processing of SMC composite parts. Obviously, any number of conventional processes could be applied to a molded part. Deflashing, bonding, and coating tend to be typical of a molding and value-added operation. The next segment wraps things up and gives a high-level view of what it takes to get started with SMC.